Hello folks, we are once again back with the problem number 11 of this exercise 7.5. The problem number 11 is very much like the problem number 10, where we had, though it was appearing as a quadratic in the denominator, it is actually not a quadratic, it can be factored into linears, and finally it becomes three linears, which can be made a partial fraction as a over the first factor plus b over the second factor and c over the third factor. So that's how we are going to do this problem also. So for that, let's see now how we can have this broken up. Consider the 5x over x plus 1 times x squared minus 4. This x squared minus 4 can split up as x, it can split up as x minus 2 times x plus 2, because it is any quadratic which is of the type a squared minus b squared splits up as a minus b into a plus b. So that's how you get this. Once you get this, these are three linear factors, so which can for which we have a partial fraction a. Let's have this assumption. Consider this as a over x plus 1, b over x minus 2, and c over x plus 2. Let's have the substitution. Then in that case, as we know that once we have to have this equalized, so it is 5x over x plus 1 times x squared minus 4, becoming equal to a over x plus 1 plus b over x minus 2 plus c over x plus 2. We know that this is our LCM, so each of the fraction has to be multiplied so as to get this LCM. This fraction has to be multiplied by these two, this fraction has to be multiplied by these two, and this fraction has to be multiplied by this two. So therefore this becomes the numerator a, it's a times x minus 2 times x plus 2, b times x plus 1 times x plus 2, and c is x plus 1 times x minus 2. All of them have the same denominator, so we write the common denominator x plus 1 times x minus 2 x plus 2, which can cancel each other from both sides. So therefore you're left with just that. So here now you have a over x, a times x minus 2 times x plus 2 plus b times x plus 1 times x plus 2 and c times x plus 1 times x minus 2 is equal to 5x. This is the expression that we're getting. For us, it is for us to find out the ABC. So for that, we'll make substitutions. It's very clear from here that we can substitute x as -1, x as 2, and -2. That will give you the answer. So let's go in for the substitution. Let x be -1. So if x is -1, this term, b term and c term will vanish, only a term will stay. So you'll have a times -1 minus 1 minus 2, it's -3, and -1 plus 2, so that's 1, and on the other side it's -5, so a can become 5 over 3. Next we make a substitution, x as 2. So if x is 2, a term will vanish and c term will vanish. We'll get the b term. b is 2 plus 1, that's 3, and 2 plus 2, that's 4. And here it is 5 times 2, which is 10. So b can become 10 over 3 times 4, which you can cut. So it can become 5 over 6. So b can become 5 over 6. X can be also -2. So if x is -2, then we'll have a vanishing and b vanishing, will be left with the c. So c will be it's -1 and -4, and here it is 5 times, so that's -10. So you will be left with -10 over 4, which can be cancelled 5 times and 2 times. So you'll get c as -5 over 2. That's it. Now it's very easy to get the integral. I now becomes integral of, so it is 5x, but it's splitting up like this. So this is going to be the place from where you're going to get the substitution. A for us is 5 over 3 x plus 1 in the denominator. B is going to be 5 over 6 x minus 2 in the denominator, and c is going to be -5 over 2 with x plus 2 in the denominator dx. So let's have that split. You will have 5 over 3 integral of dx over x plus 1. Next one, it is 5 over 6 integral of dx over x minus 2, negative 5 over 2 integral of dx over x plus 2. So let's have all this. 5 over 3, it's log x plus modulus x plus 1. 5 over 6 log modulus x minus 2, negative 5 over 2 log modulus x plus 2 plus c. It's pretty easy because all were linears in the denominator. We'll just have a quick checking. Perfect. So this is our 11th one where we have these linears placed and done like. This should be all for today. With more videos, let's meet again. Thank you. As I always tell, please popularize the channel, see that, spread a word and see that we are there everywhere. Yeah. Thank you.